In the previous section, we were given a compound inequality and we were asked to draw the appropriate solution graph. Here we're going to be given the solution graph and we're going to work the other way. We're going to find the corresponding compound inequality. So let's do a few of these. Here we need to translate information from a number line into equation notation. This isn't anything to get excited about. We simply need to be careful with direction of shading and whether we see parentheses or brackets. So here we go. Let's take this first one. Since our shading is in between two values, we know that we have an AND compound inequality. So our values of x are going to lie in between two values, 0 and 4. So here we have a parenthesis, so we're going to have a less than sign and 0 because 0 isn't going to be included in our compound inequality. So x is going to be greater than 0 and x is going to be less than or equal to 4. We know this because we have a bracket here at 4, which means it's included in our solution set. So anytime we have an AND problem, it's actually going to look like this, and we should get really familiar with this because we'll see it a lot more in mathematics, this sort of compound equation notation. So let's do a few more of these. Let's look at the next one. Here we have two separate regions shaded, which tells us that this is an OR compound inequality. Let's just be careful to get our signs correct. We always have to watch out for our signs, even with inequalities. So here we go. We're looking for this region, and this region is defined by all the values that is less than minus 3. So x is going to be less than minus 3, but we're also going to include minus 3 in our solution interval. So because we have a bracket here, so we're going to have a less than or equal to minus 3. All right, so let's look at this section. Here we're looking at this parentheses, looks like it's at 1/2. So we're looking at all the values that are greater than 1/2. So x takes on all the values greater than 1/2. Or this is actually minus 1/2. Excuse me. X is greater than minus 1/2. And since the parentheses is at minus 1/2, we don't include that point in our solution set. All right, let's take a look at the next one. We have two separate regions shaded here, so this is going to be another OR compound inequality. So let's go ahead and just work from left to right. Here we're looking at all the values that are less than 2. We have a parentheses, which means we're not including 2 in our solution set, so we have x is simply less than 2. All right, so let's deal with the second one. This shaded region represents all the numbers that are greater than 9. We're not including 9 in our solution set because of the parentheses, so x can take on all the values greater than 9. All right, not a whole lot to these, just trying to get familiar with them, especially with the notation. Here we actually see a very familiar compound inequality. We saw this in the previous video, where this actually defines something called cosine and sine. So what we have is our shaded region is popping back and forth between minus 1 and 1. So we have an AND compound inequality where our values of x are going to be in between minus 1 and 1. We see brackets on the end of these, so we're going to include the endpoints in our solution sets. So we have minus 1 is less than or equal to x is less than or equal to positive 1. All right, now a key when we see such compound inequalities as this is that the arrows are always going to be pointed left. We're only going to be either using less than signs or less than or equal to signs. And this makes sense because it's going to be, all the values are going to be in between these two values. The values are going to be greater than or equal to this value and less than or equal to this value. So it's helpful if we can be able to read them individually both directions. So let's look at a few more. Here we have one value, one region shaded, so our values are going to be in between the endpoints 23 and 27. So we have x is less than or equal to 23, and less than or equal to 27. So x is greater than or equal to 23, but less than or equal to 27. We include the endpoints because of the brackets, so here's the equation notation for this particular number line. All right, let's do one more. Here we have two separate regions, so let's deal with them individually as an OR compound inequality, and let's look at them from left to right. This region is representing all the values that are less than minus 1. The parentheses tells us that we're not including minus 1 in our set of interval values, so we have x is less than minus 1. I think I'm running out of room here. X is less than minus 1. All right, now to the right, this region represents all the values that are greater than 1. We're not including 1 because of the parentheses, so we have all the values for x are greater than 1. All right, so not a whole lot to these once we get the notation down. We just want to be careful with noticing if we have two different regions shaded or just one region shaded. If we just have one region shaded, that means that we're dealing with an AND compound inequality, and we can actually easily pick these off because we can see the two endpoints, and all of our values are going to be in between the two endpoints. All we need to look for is if we have parentheses or brackets. So that means if we exclude or include the endpoints. And if we have two separate regions shaded, we have an OR. We have an OR compound inequality, and we actually have two different sections that we'll define individually. And we just want to still make sure that we're careful with our signs and watching for the parentheses and brackets. So let's get really familiar with these because we'll be using these quite extensively in this section. So I'll see you soon.